Hi and Assalamualaikum. Today, our topics is Cremer'S rule. Before we begin, I would like to introduce the team members of this presentation. My partner is Muhammad Hasrul bin Zuzairi and myself is Muhammad Afnish bin Muhammad Afif. Now, let's move on to the introduction of the Cremer'S rule. Firstly, Cremer'S rule is a method used in linear algebra to solve a system of linear equations with the same number of equations and variables. It uses determinants to find the value of each variable. The rule works only when the determinant of the coefficient matrix is not zero, which means the system has a unique solution. Cremer'S rule is easy to apply for small systems of equations and help us understand the relationship between matrix and linear equations. Now, let's move on to the next phase, which is the purpose of study. The main purpose of the study is to demonstrate how Cremer'S rule, a mathematical method for solving a system of equations. It can be used in everyday life, particularly in solving real-life cost-sharing problems when exact data such as price are unknown. By using the totals that each person paid for different item combinations, we can form a system of 3 equations and apply Cremer'S rule to find the actual cost of each item. So now, we're gonna start with goals. Okay. Now, the first thing when I'm trying to identify and try to understand what is Cremer'S rule is, first I would like to know how to calculate using the Cremer'S rule. Next is how do we solve a 3x3 equation by using the Cremer'S rule. And lastly, I hope that my partner can show me and teach me how to find the value of x, y, and z.
Therefore, the question that will be discussed is as shown below. Solve for x, y, and z by using Cremer'S rule for the following system of linear equation. The linear equation is negative 3x plus 2y plus 4z equal to 7, negative x plus 2y plus 3z equal to 8, and 5x plus y minus 2z equal to 3. First, I rewrite the linear equation to the metric form and let it as A. For the coefficient matrix is negative 3, 2, 4, negative 1, 2, 3, 5, 1, negative 2. For the variable matrix is x, y, z. For the constant matrix is 7, 8, and 3. I want to calculate the determinant of A by expanding along the second column. Each element in the second column is multiplied by the determinant of its corresponding minor matrix, including the correct sign. We will get negative 2 multiplied with negative 13 plus 2 multiplied with negative 14 minus 1 multiplied with negative 5, which is 26 minus 28 plus 5 equal to 3. Now, I want to find AX. The first column of coefficient matrix replaced by the constant matrix. I will find AX by expanding along the second column. Each element in the second column is multiplied by the determinant of its corresponding minor matrix, including the correct sign, which is we will get negative 2 multiplied with negative 25 plus 2 multiplied with negative 26 minus 1 multiplied with negative 11 equal to 50 minus 52 plus 11 equal to 9. Next, I want to find AY. The second column of coefficient matrix replaced by the constant matrix. I will find AY by expanding along the third column. Each element in the third column is multiplied by the determinant of its corresponding minor matrix, including the grad sign. We will get 4 multiplied with negative 43, negative 3 multiplied with negative 44, negative 2 multiplied with negative 17 equal to negative 172 plus 132 plus 34 equal to negative 6. Now, I want to find AZs. The third column of coefficient matrix replaced by the constant matrix. I will find AZ by expanding along the second column. Each element in the second column is multiplied by the determinant of its corresponding minor matrix, including the grad signs. We will get negative 2 multiplied with negative 43 plus 2 multiplied with negative 44 and negative 1 multiplied with negative 17 equal to 86 minus 88 plus 17, which is 50. To find the value of x, y, and z. The formula to find x is ax over determinant of a, which is 9 over 3 equal to 3. The formula to find y is ay over determinant of a equal to negative 6 over 3 equal to negative 2. For the last, formula to find z is az over determinant of a, which is 15 over 3 equal to 5. For the result, we successfully use Cremer'S rule to find the value of x equal to 3, y equal to negative 2, z equal to 5. This discussion shows that how linear algebra can solve the problem. This kind of thinking also can apply in real-life situations like accounting and budgeting. That makes mathematics very useful and successful.
Before we start our conclusion, I would like to thank to Hasrul for calculate and teach me how Cremer'S rule works. And let's begin. In conclusion, since the determinant of the coefficient matrix is not zero, Cremer'S rule is applicable by calculating the required determinants, and we were able to find the exact values of x equal to 3, y equal to negative 2, and z equal to 5. This shows that the system has a unique solutions and demonstrates how Cremer'S rule works. And Cremer'S rule can be used to solve systems of linear equations efficiently. Thank you.